Good to see so many people here on such a wet day. My name is Dr. Peploski. I am Director of Freshman Chemistry here at Peploski University. I'm also a Clarkson alumni from the class of 1985. And today we're going to take a look at the wonderful world of chemistry. And so, as we talk a little bit about chemistry, we're going to try to find some ways that, which pertains to us in our everyday lives. So, when I start this show, particularly with children present, I always start with a question. The question is, if we're here to talk about chemistry, what is chemistry? What is chemistry? What is chemistry? What is chemistry? Chemistry is like that. That's, a science. Chemistry is a science, and it's a science of studying chemicals. And chemicals are everything that make up the world around us. Anything you can taste or touch or feel is made up of chemicals. And the study of those chemicals is chemistry. So if I choose to study the chemicals that make up this bench top, not very interesting. Chemistry gets interesting when things start to change. And those changes we call chemical reactions. So let's take a look at a simple chemical reaction. Take a look at a simple chemical reaction. You'll note I put on my safety glasses here. Not helium gas, but hydrogen gas. Hydrogen is a gas which is lighter than air and yet is combustible. It burns. Okay, so that was an example of the combustion of hydrogen gas. I always bring a spare just in case I screw up the first one, so we might as well get this out of the way. Let's take a look once again at the combustion of hydrogen gas. Another balloon filled with hydrogen. Let's take a look at the combustion of hydrogen. It needs oxygen. In the first case, where I had a balloon filled only with hydrogen, it had to find the oxygen from the room around it to burn. In the second case, I mixed the two chemicals together in the balloon. When I touched it with a match, I got a dramatically different result. So chemistry is not just about studying reactions, it's about controlling them, making them behave the way we want them to behave. Okay, so that's an example of a simple combustion chemical reaction. When I do this show, I always make it. I shook the bottle. What did shaking the bottle do? Shaking the bottle mixed it. What did it mix in as I shook that bottle? Actually, if you look look carefully at the bottle, what's happening? It's getting lighter. The pink color started to go away. When I shook it, what did I do? I mixed something in, something from up here. What was up there? Air that has oxygen. So I shook oxygen into the mixture. This is an example of what's called an oxidation reduction reaction. And it's reversible. So the color goes away. I much prefer the pink color. If I put a little more oxygen, I can have the pink color back. So not only is it reversible, it's repeatable. And so we can let that sit there for a moment. It will turn color. Let's give it a shake, and you can get your color back. And this will go on for an hour or more. I can do it with different dyes to get different colors. And if I'm really tricky, I can even get different colors in the same bottle by having mixtures of dyes. If you let that sit there for a moment, then you can pass it around, let it turn color, let's give it a shake, and you'll be able to witness the oxidation reduction reaction. That first chemical reaction that we did, that first chemical process, gave off energy to the room. It released energy as it happened. We call that an exothermic reaction. We felt that energy in the form of heat, and we felt it as a shock wave that went through the room. I want you to guess how the energy is given off in this next chemical reaction. I want you to tell me how the energy is released in this process. Okay. How is the energy given off in this case? It's given off in the form of light. Energy is given off in the form of light. If I had a dye, I can get a color change. Now, there's no heat generated in this. The flask is cold. Where do you see this kind of generation of light? This kind of chemiluminescence, the chemical generation of light. Where do you see this happen? What about in nature? Fireflies or bioluminescence communication between animals. Or at the fair, like the Potsdam Fair that's going on downtown, where else do you see this? In glow sticks. Chemiluminescence. Chemiluminescence. All right. So. Now, if anyone doesn't get one, if any of the children don't get one or want one, you can come on down after the show. We'll make sure that everybody gets one. But any other takers? Yeah, right. Yeah, I'm waving one at me isn't going to help. Oh, yeah. All right. So now, as long as I've got you in the dark, as long as I have you in the dark here, I have a chemical solution in this bottle, and I have one simple question. What color is the solution? Is it red or is it green? Well, the answer is, like many things, it depends on how you look at it. That if we look at the light passing through the solution, we see all the colors of the rainbow that are unaffected by the light. That is the red. When we look at it at an angle, we see the color of light given back in a process called fluorescence. Fluorescence. So, red or green depends on whether we're seeing the light passing through or the light that's being fluoresced. All right, so let's turn on the lights here.